Hello my dear students, we'll be starting our e-learning system, so I'll be uploading videos of explanation and you need to watch the videos and then answer the questions in your assessment book. Keep your assessment book open and write down notes with me. Let's start. We'll start by section 2, the structure of the atom. In this lesson we have to know the observed properties of the cathode rays that lead to the discovery of the electron, and summarize the experiment carried out by Rutherford and his co-workers that lead to the discovery of the nucleus. List the properties of protons, neutrons and electrons, and define atom. As we all know what the meaning of atom is the smallest particle of an element that retains the chemical properties of that element. Inside the atom there is a dense part called nucleus. The nucleus, most of the mass of the atom is concentrated inside the nucleus. This is why it is a dense part. Inside the nucleus we have two parts, protons and neutrons. The protons have a positive charge and the neutrons have a neutral charge, which means that have no charge. Around the nucleus there is a negative charged particles called electrons. So we have three subatomic particles, protons, neutrons and electrons. The protons and neutrons are found inside the nucleus and the electrons are outside the nucleus. All of the three are called subatomic particles. But keep in mind that all the subatomic particles have the same properties even in different atoms, which means that the protons inside the sodium have a positive charge. The protons inside the chlorine has also positive charge. The neutrons inside the hydrogen have no charge. The neutrons in chlorine have also no charge. So all the subatomic particles have the same properties even in different atoms. Look here. The relative electric charge of the electrons is -1, as we said. The relative electric charge of protons is +1 and the relative electric charge of neutrons is 0. The mass number is 0 and the mass number of protons is 1. The mass number of neutrons is 1. The mass number of electrons is 0, which means it has very small mass, 0.001, which means have a very small mass that can be neglected. Let's think together how they discovered the electrons. A scientist called Thomson, let's look here. A scientist called Thomson get a cathode ray tube. The cathode rays were passed inside the cathode ray tube, as you see, and the cathode rays were deflected away from the negative charged object. This suggests that the cathode rays are composed of negative charged particles that are called electrons. That's how the two charges have the same charge, negative and negative, so they will be deflected. The scientist called Robert Millikan oil drop experiment measured the charge of an electron. After, we have the discovery of the atomic nucleus. How they discovered the atomic nucleus. Scientists called Rutherford and his associates make an experiment called gold foil experiment. Okay, let's look. He used the alpha particles. Rutherford aimed the positive alpha particles into a gold foil. Here is the gold foil. The expectations were the alpha particles will pass through the gold foil that has only negative charge, as Thomson said. But the surprise that some alpha particles were deflected back. This suggests that the gold foil has some positive charge, which is called nucleus. Again, to understand the Rutherford experiment, here is the beam of positive particles. This beam hit the, imagine this circle is the gold foil, and the beam of positive particles hit the nucleus. When it hit the nucleus, the red rays deflected, and the black rays will pass easily. at the positive particles when it hit the nucleus have a positive also charge, so they will be deflected like the red arrows, and the one who are away who's away from the nucleus, the electrons have a negative charge, so they will pass easily. Okay, all the atoms contain nuclei that are made of protons and neutrons. As I said, the protons have a positive charge and the neutrons have no charge. This except for the hydrogen. The hydrogen contain protons only, 1 protons and 1 electron, no neutrons. The atoms are electrically neutral. What the meaning of electrically neutral? Electrically neutral, that no charge. The atoms have no charge, no end result. The net result of the charge is 0. Why? Because the number of protons are equal to the number of electrons. As مثلا the sodium have 11 protons and also 11 electrons, so positive 11 minus 11, so they will cancel each other. Positive 11, negative 11, so they will cancel each other. So the atoms are electrically neutral. Why? Because the number of negative electrons are equal to the number of positive protons, so they will cancel each other. Now let's open your assessment book. If you don't have your books, you can see the Google Classroom. I have uploaded the sheets, the classwork sheets, on the website of the school. First, answer the following questions in the space provided. First, number 1, in the cathode ray tubes, the cathode ray is emitted from the negative electrode, which is called what? Think. Cathode. The cathode ray is emitted from the negative electrode, and which is called the cathode. The smallest unit of an element that can exist either alone or in molecules containing the same or different elements is, the smallest unit is called atom. A positive charged particle found in the nucleus is called, the positive charge, of course, protons. The nuclear particle that has no electric charge is called neutron. Number 5, the subatomic particles that are at least mass and most massive, that respectively are the least mass electrons, of course, and the most mass is neutron. Number 6, a cathode ray produced in a gas-filled tube is deflected by a magnetic field. A wire carrying an electric current can be pulled by a magnetic field. A cathode ray is deflected away from a negative charged object. What property of the cathode ray is shown by this phenomena? Why the cathode ray is deflected? Why? The particles that compose cathode rays are also negatively charged. That's why they are deflected. They have the same charge, so they are deflected from each other. Number 7, how would the electrons produced in the cathode ray tube filled with neon gas compare with the electrons produced in the cathode ray tube filled with the chlorine gas? The electrons in the neon, electrons in the chlorine, they behave the same way. Why? Because electrons do not differ from elements to element. As I have mentioned, all the subatomic particles have the same properties even in different elements. So the answer is, they behave the same way because electrons do not differ from element to element. Number 8, A. Is an atom positively charged, negatively charged, or neutral? The atom has what charge? Positive, negative, or neutral? Neutral. Excellent. Explain how an atom can exist in this state. Why the atom is a neutral charge? Yes, because it has the number of positive protons equal to the number of negative electrons, so they will cancel each other. Number 9. Don't get panicked from this, it's very easy. Below all illustrations of the two scientists' conceptions of the atom, label the electrons in both the illustration with the sign negative sign, and the nucleus in the illustration to the right with a positive sign. On the lines below the figure, identify which illustration was believed to be correct before Rutherford Goldfeil experiment. and which was believed to be correct after Rutherford-Gould experiment. Okay, the question is divided in two parts. First, label the electrons in negative and label the nucleus with positive. The electrons here in this, inside each circle, put negative sign because they are electrons. They are like Blum's embodying theory. This is the electrons revolve around the nucleus in an electron cloud. So put negative signs inside each circle. The next diagram here. Put negative sign on the circles that around, and inside here put positive sign. Why? Because this is the nucleus. Okay. On the lines below the figure, identify which illustration was believed to be correct before Rutherford-Gould foil and which was believed to be correct after Rutherford. Which one is before and which one is after? Of course, this one before Rutherford. According to the expectation, the alpha particles will pass through the gold foil that has only negative charge, so all the rays will pass easily. But in the second diagram, after Rutherford experiment, he found that there is a dense part have a positive charge here. So this is before and this is after. A before Rutherford experiment and B after Rutherford experiment. Number 10. In the space provided, describe the location of the subatomic particles in the labeled model of an atom of nitrogen below, and give the charge and relative mass of each particle. It's very easy. Protons is number A, so define protons. Protons is a positive and have a relative mass particle and should be located in the nucleus, inside the nucleus. Neutron is a neutral charge ending by letter L, which means has no charge, and a neutral or relatively massive particle and should be located also in the nucleus. Number C, electron, a possible location of this particle. The electron of number C, of course, that revolves around the nucleus. So what is the electron? Negative with a low mass. You have to know that the electron have a very small mass. So nucleus, so electron negative with a low mass should be located in the cloud surrounding the nucleus, in the electron cloud, not inside the nucleus. Thank you, and see you in the next video.